So hopefully you looked at some examples in the API documentation. If not, pause the video, go poke around in the Java docs. It will really just become familiar with it. Look at some of the stuff we've already talked about, such as the string class, things along those natures. It will really help you out. But for now, let's examine the math class directly within this lesson, and so because we're going to use it quite a bit. So one of the first things we're going to talk about is the ABS method, or absolute value. So you can see here that it's public, of course, it's static, and we'll explain what that means on the next slide, I think. It returns an integer, and the method name is absolute, or ABS, and it takes in a integer as an argument. So here, int y equals math.abs -3. So what do you think the answer is? Well, if you paid attention in math class growing up, you should know that it's 3, right? It returns the absolute value. And of course, there's a double method version of this as well. Notice here that the method name is the same, but it has a different return type. So method name is the same, but it has a different return type. Let me switch colors here. So here we got an integer, and here we got a double. Even though these two methods have the same name, what we refer to as their signatures is different, okay? Because the return type is part of the method signature. What about the max method? It returns the larger of two numbers passed as arguments. So in this case, what do you think x would be? It's going to be whatever's the bigger of this argument and this argument. So hopefully you got 34. If not, I'd be concerned. And then, of course, there's a double method for this as well. So you can say here we have max, and it returns an integer. Here we have max, and returns a double. And then notice that this takes doubles as arguments, and this takes integers. So we mentioned static modifiers on the previous slide, but what is a static modifier? A static modifier means that the method is called directly from the class, meaning we don't have to instantiate an object. So we'll talk a little bit more about this later, but for now, just know that all methods in the math class are static methods, and those are also called class methods. And you can see in the example here that we are calling ABS, or the absolute value, by prefacing the method with a class name and the dot operator. So math.abs. This is the class name, right? This is the method. So go ahead, pause the video, and what I want you to do is try to come up with a statement that will update a variable x's value so that x gets the absolute value of its original value. So you can use this kind of as an example, but we're going to take x, and whatever x is, we want the absolute value of x, and we're going to store it back in x. So go ahead and pause the video now. I'm going to wait a couple seconds. Okay. Hopefully you paused it. Hopefully you tried. But this is what you should have gotten. Oops. You should have gotten this right here. Math.abs x. So this function is going to take whatever is stored in x, find what the absolute value is, and store it back in x. So now that we're done kind of talking about static modifiers, we'll come back to that later. But let's finish up our discussion of some of the other methods in the math class. First, we have min, which is going to return the minimum of two values. All right, so it's the opposite of the max. And of course, we have an int version and a double version. We also have power, which will take a number and raise it to another number. So in this case, it's going to take in a number and raise it to the second number. In this case, we call it number and power. So here we have 2 raised to the 3, which is 2 times 2 times 2. So of course, that'll equal 8. We also have random. And if this is, and these are all static classes, this is going to return a double value, and it's going to be a uniformly distributed value between 0 and 1, but not including 1. All right? So if you remember from your number theory, you have 0 to 1, and we would say it includes 0, but it does not include 1. All right, so let's take a minute to talk about what does this uniformly distributed value mean. A uniform distribution means that you'll have an equal chance to pick any number between 2 values. This is kind of like rolling a single die. The probability of you rolling any particular number is the same. No matter how many times you roll the die, you're always going to have an equal chance of rolling a 1, a 2, a 3, a 4, a 5, or 6. Right? Doesn't matter if you roll a million times. The more you roll it, this should look pretty even with the number of times that you've rolled that number. Okay? Now, a normal distribution, this is a uniform distribution. A normal distribution is what you would know as a bell curve. And this is where you have a higher probability to reach values in the center than near the upper and lower limits. And this is what you'd get if you were to roll multiple dice and then you were tracking their total value. Okay? So if you were to roll 2 or 3 dice, you would start to get this curve. And if we keep going down this road, we're eventually going to get into talking about the central limit theorem, and I don't want to get all statistical on you. And so it's definitely outside the scope of this class. So we're not going to turn our discussion of the math class into a math class. Yeah, see what I did there? So coming back to some more of the methods in the math class, now that we're done with our little foray into statistics, we also have the round method, which does exactly what you would expect. It rounds to the closest whole number. And we also have the square root method, which will return the square root of a number. So the square root of 4 would be 2, so on and so forth. Okay, and no, this is not the squirt method. It's a square root. Okay. And of course, again, it's the root of a number. So the square root of 9 is equal to 3, right? All right, we all know our math. So one interesting thing that you should know is that it is legal to pass an integer value to a method that accepts a floating point argument. So take a look at the following example. And according to the book, Horton's law says that the length of a river is related to the area drained by the river in accordance with this formula. All right, so length of the river is approximately equal to 1.4 times the area raised to 0.6. All right, I don't know, I'm not a geologist, I don't know where this comes from, so just we'll have to trust the book on it. So if we wanted to implement this in Java, this is what it would look like. Note that here we are using the int area as an argument to a method that requires a double. Okay, so we're taking an area and we're passing in, area is an integer, and this is supposed to be a double right here. The compiler is automatically casting area to a double for you. All right, so area is an integer. This argument is supposed to be a double. The compiler sees what you're doing and it says, hey, you know what? I can cast the int as a double. We can use it. We're good. Who wants pi? Well, the math class has a pi constant for you. So just as a quick recap, math.pi is a class variable, and math.e is the natural logarithm, or 2.718281828459045235, just in case you were wondering. So yeah, pi. If you remember what pi, it's the ratio between the circle's circumference and its diameter. So just a recap for you.